Circular motion, this chapter is circular motion. Adding is circular motion. This chapter is simply, if you understand, a particle is moving in a straight line. This is known as straight line motion. Car is a car. This car is moving on a road. Its motion is straight line. Then what is the reason like this particle or this any object is taking a circular path? What is the reason like this particle is moving in a straight path? We are saying velocity is rate of change of displacement, ds over dt. Acceleration is dv over dt. Clear? S is equal to ut plus half at square, v is equal to u plus at. This is what we have learned in one dimensional translation motion. V S is equal to ut
Right.
plus half at square. Clear?
Yes, sir.
V square equal u square plus 2as. But in case of circular motion, the particle is moving in a not in a straight path, it is moving in a circular, not in a circular path, it is in a curved path. It is in a curved path. Clear? Now, why this particle it is moving in a straight path? Why is it taking circular path? Why is it taking curved path? There is some reason behind that. This is radius r. Clear? This is circular path. This path is circular path. So there are
Yes,
some
sir.
terminology. In a straight line motion, we are saying velocity. Here, angular velocity. In place of displacement as we are using theta, angular displacement. I will explain, don't worry. Only meaning is changes, but meaning is same, but the symbol is different. Okay. It is also displacement. It is also displacement. But omega is in
Okay, sir.
circular path. Clear? Similarly, A is what? Acceleration. Clear? Rate of change of velocity. Here, angular acceleration. Alpha is d omega by dt. In place of A, there is angular acceleration. Omega is equal to omega naught plus alpha t. Like this. In place of S, this theta, omega naught t ut plus half a t square, a t square. V square is equal to u square means omega. Final velocity square equal initial means omega naught. There plus
Okay, sir.
2a as means theta. So nothing is changed, only the symbol is changing. Clear? There V in place of
Yes.
V, we are using omega here. Now what is omega? What is angular displacement? Let us understand with the help of this example. Not example, I think. When a particle is moving in a circular path, let us suppose this is the center of the circular path, and this is the radius. Clear? And this is the mass. This is the particle. This particle is having the mass small m. If you are the observer, and you are at the center, and if you are looking this particle is moving. Initially, it is at here. After some time, this particle is moving this much angle. How much angle? This angle.
This, sir.
Let us suppose this angle
Yes.
is, you can say d theta. How much? D theta. Clear? Initially, this particle is
Okay.
here. Let us suppose this time is t. Here, this particle reaches t plus dt. In this time, this particle travel how much distance? Linear distance, you can say. This is the distance traveled by the particle. This from A to B, how much? Let us suppose this is the distance, okay? How much? Ds. Clear? Or if
Okay,
I
sir.
make it very, very simple, or you can, I think, make it or also. This d theta, clear? This observer, for example, if you are here, okay? This particle move from A to B. Then how much angle? This is the angle. Clear? This is known as angular displacement. This d theta, na, this angle, how much angle travel? This is known as angular displacement.
Sir, then what does ds mean, sir?
I will tell. This is angular displacement. What is ds? ds is a very, very small distance. I have shown like this, but actually it is straight. Clear? ds is linear
Okay.
displacement. Linear displacement. I have shown like this. Actually, it is ds is very small like this, almost straight. Clear?
Okay, sir.
This is d theta is angular displacement. Clear? In time dt, it travel d theta. Clear? Initially, this particle is at A. Then how much distance it travel? D theta. Okay. In one rotation, in one rotation, if I ask you, in one rotation, how much angular displacement, how much linear displacement? If I ask angular displacement, and one is linear displacement.
Okay, sir.
You please tell me, if a particle complete one rotation means this entire, it started from A, come back to A. Then how much angular displacement? 2 pi. Clear? Okay.
Okay, sir. Yes,
And
sir.
in one rotation, how much linear displacement? 2 pi r. Clear? Clear or not?
Yes, sir.
So we can say in 2 pi, this is radian, okay? This is 2 pi radian. In 2 pi radian, how much particle travel? 2 pi r. Okay. In one radian, how much it travel? 2 pi r by 2 pi. Meaning what? One radian means, what is the meaning of this? Center. When this angle is 1 radian, how much? This is 1 radian. Clear?
Okay, sir.
Then this particle will travel a distance equal to the radius. Meaning is that. Okay?
Okay.
Is it clear or not?
Yes, sir.
So, if I ask like in 2 pi, it travel 2 pi r. Okay? If I ask in theta, if it travel theta, then how much? How much linear displacement? 2 pi r by 2 pi into theta. R theta. R theta. In theta radian, it travel this much linear distance, linear displacement, LD. Clear?
Okay, sir.
And you can say this S is R theta. Up to this, any doubt? Tell me.
Sir, can you please explain the r theta again?
See, in 2 pi, there when it travel 2 pi, then how much distance it travel? 2 pi radian. 2 pi r.
Yes, sir.
Clear? When it travel only theta, like A to B, theta only. In this theta, how much? Theta radian, how much it will travel? 2 pi r by 2 pi into theta. ठीक होगा? That is r theta.
Okay.
And what is this? Meaning is that this is the center, this is theta, r, then this will be how much? Linear displacement, r theta. This is known as S. How much it travel? Let us suppose AB, r theta. Clear? Then if you look at carefully, this theta is what? Theta is S by r. This is S, okay? S by r. What is S? It is arc length, arc by radius. Yeah, you have learned this, I think. Mass. What is theta? Theta is angular position, angular displacement, sorry. Clear? Is it clear? Is it clear, Dinesh?
Sir, clear, sir.
Okay. If I ask like one thing, like S will be r theta. What is S? This is r. This is also r. Let us suppose it travel theta. Then linear displacement, how much? This is from A to B. How much it travel? S. This S is r theta. S will be r theta. If you differentiate, this will be, can I write like this? Delta S by delta T. R delta T by delta T. Can we write or not?
Yes, sir.
If you take one, delta T is tending to 0. Very, very small. Then this delta S also, it become ds r d theta by dt. Then this is known as velocity. What is this? T.
Velocity.
This is omega. What is omega now? This is
Sir,
instantaneous,
d theta by dt.
but it is instantaneous angular velocity. Clear?
Okay, sir.
And V is velocity, instantaneous velocity. Clear? V is
Okay, sir.
instantaneous velocity. Okay. If I
Okay.
ask like one question, if I ask to you, hmm, what is the, since theta is angular displacement, okay, angular displacement, since theta is angular displacement, then my question is, what is the direction? What is the direction of theta? Many books they have
Sir,
asked
it
like what is the,
changes.
write down
Sir,
direction
it
is,
changes at
is
each
a,
point, sir.
you can write it is a axial vector. What? Theta is what? It is a axial vector. Its direction is along the axis. Clear?
Okay.
It is a axial vector. Its direction is calculated by, its direction is calculated by right hand thumb rule. What is this? I will explain. Right hand thumb rule. Thumb rule. Clear? Meaning is what? It's RIGST. Sorry. It is RI, right. For example, if a particle is moving like this, A, it has velocity in this direction. Let us suppose velocity magnitude is constant. Clear?
Okay, sir.
If you look at carefully, while moving from here to here, it travels this much angle, that is 90 theta. It is moving like this now. Clear? What is
Okay, sir.
axis? Axis means you can write any straight line. If axis is not given, always take straight line passing perpendicular to the center. Clear? So if a particle
Okay,
is moving like this, anti-clockwise, if you take your right hand thumb rule, right, move your fingers in the direction of motion like this, all the fingers. Then your thumb will point in which direction? Outwards. Clear? Like this.
okay, sir.
These fingers, all the four fingers must be in the direction of motion of object. It is moving like this. Clear? Then your thumb is pointing in which direction? Along the axis, outwards. Clear?
Okay, sir.
If the motion is like this, clockwise, then thumb will be inside. Clear?
Okay,
Anti-clockwise, simply you can anti-clockwise means if a motion is anti-clockwise, then theta is along z-axis, means along positive k. If it is clockwise, clockwise, then theta will be minus k. Okay. If you take this
okay,
x,
sir.
this is y, then perpendicular to this is z side minus z. Clear? So direction, it is the
Okay,
axial vector. So axial vector, theta is a axial vector, angular displacement. Clear? Displacement in terms of angle. Any doubt?
yes,
So I
no,
think
sir.
you have learned like this average velocity.
Sir, can you
Average
please show
velocity.
the previous slide I'm
Yeah,
writing,
sure,
sir?
sure. You can write. Please write.
Okay.
Clear?
Yes, sir.
Average velocity
Sir,
is, please write.
uh,
Written?
1 minute, sir. Yes,
Please
sir.
write. Okay. Average velocity is delta S by delta T. Average displacement by time. If I ask instantaneous velocity, you have learned ds by dt. In the similar way, there is average angular velocity, omega. Clear? In place of s, there is theta. Similarly, instantaneous angular velocity is d theta by dt. Differentiation, little bit.
Yes, sir.
Okay, then write
Yes, sir.
one small question. If theta is, write on the question, if theta is means angular displacement is given 2t square plus t. Then find omega in 2 seconds. First part, okay? And
Okay.
at 2 seconds. You need to find omega in 2 seconds. 2 seconds means in 0 to 2 seconds.
Two.
And find omega at 2 seconds. Solve this.
Okay.
Solve this.
Sir, 1 minute, sir.
Sure. Easy only. So
average, sir.
I will solve, okay? You just check your answer.
Okay. Okay.
Let's differentiate this, okay? Omega. I am asking first omega in 2 seconds. So omega will be 2 second means 0 to 2. Delta theta by delta t. It means theta final minus theta initial by t final minus t initial. Final means at what time? 2 second. Theta initial means at 0 second. 2 minus 0. So theta at 2 second how much? 2 2 is 4 plus 1 minus it is 0 divided by 2 minus 0. So it will be 4 2 is 8 or 1 9 9 by 2. How much? What is the answer? 2 4 is 8 2 5 is 10. 4.5 radian. Theta is in radian by second. Clear?
Okay, sir.
Next is like theta is given 2t square plus t. Theta is it. Theta is 2t square plus t. Differentiate this. You will get the instantaneous angular velocity, that is omega. 2t square plus t. If you solve this, you will get 4t
Sir, 40.
plus
I
1.
got you.
Then omega. This is the instantaneous. Now if they are asking at what time? At time, this is a question. 2 second, okay?
Yes.
At t is equal to 2 second. Then put the value of t is equal to 2. Answer will be 9 radian per second. Clear?
Okay, sir.
Next is write down. This is I think you have learned or not. I'm telling. This is the particle is moving in a circular path. Clear? This is center.
Okay.
Center is R. Center to any point there is a radius. If you look at carefully, when a particle is moving in a circular path, it has a velocity like this along tangent. It is like this now. Clear?
Okay, sir.
And if you look at carefully, the angle between the R and velocity is 90 degree. Always 90 degree. Clear? So this formula, whatever you have learned, V is equal to R omega, which you have solved. Here omega will be, V will be perpendicular. What? V will be perpendicular to the R. What is this R? From center, okay, center. Clear? And this formula particularly valid for circle or circular motion. If you want to apply for circular, okay, this is for every curved path, okay. Meaning is that, for example, you are standing at a point. There, you are standing at a point, and I think let us suppose one example. This is the point B, and here the particle is moving with velocity 3 meter, 10 meter per second. There, and this is 4
Okay.
meter. 4 meter. If I ask what is the angular velocity B of B with respect to A, then you will write omega B minus omega A. Since A is fixed, it होगा, it is 0. Clear?
Okay,
A
sir.
is fixed now. You are standing here. According with respect to A means observer is here. So according to A, what is the angular velocity? So formula is V perpendicular. This is perpendicular to R. Clear? That is 10 by perpendicular velocity divided by r. R is 4. So what is the answer? You will say 4 2s are 8. Clear? 4 5s are 20. 4.5 radian per second. Clear?
Okay, sir.
Let us suppose after some time this particle reaches here at point C. Then if you are looking this particle, for example, B particle is here. Particle C went here. Not C, it reaches the position C. Then you will move your head like this. Clear? Then you will say this is R. Clear?
Okay, sir.
You will rotate your uh, head now. Then my question is, let us suppose, let us suppose this angle is this angle is 37. How much? 37. Then what is the angular velocity of C at point C with respect to A? Can you solve?
Sir, 1 minute.
My question is 10. Here also 10. Telling this is also 10. Speed is constant.
Sir, 1 minute. Yeah.
Yeah, so
Sir, can you solve it?
yeah, I will solve. I'm asking like still first you try. Concept is omega means V perpendicular by R. V should be perpendicular to the R. If 37 angle means this is how much? Cos 37 is base by hypotenuse. Base is 4. Hypotenuse, we don't know what is x. Cos 37 is 4 by 5. X will be 5 meter. Clear?
Okay, sir.
This is 5. If you look at carefully, if this is 37, 90, this is how much? 53. This is 53. Clear?
Okay, sir.
It should be velocity must be perpendicular to the R. So this component of this velocity is V. This should be perpendicular to R. Meaning is that na V perpendicular. Clear? This is R.
Okay.
So I need to find this. You please tell me if this is 53, this is 90. How much this? Total angle is 180 degree. It will be how much? 37. Clear? 90 plus 53, that is 143. 180 minus 143 is 37. So the component, this will be here. This V will be what? 10 cos 37. Cos 37 is 4 by 5. So velocity will be 4 meter per second. This V, that is 4 meter per second, is perpendicular to the R. R means from the observer. Clear?
Sir,
So omega,
it's very difficult to understand this, sir. Can you please repeat like from starting?
sure. Omega C, C. Initially, this particle is point B. Okay. Here you can easily understand this V. This V is perpendicular to the R. This R means from observer to this point B. This R. This R.
Okay, sir.
Here you can easily understand this V is perpendicular. Directly I have written 10 by 4. Okay. But in this question,
Okay.
like This particle is moving like this. It is moving. At point C, once it reaches at point P, point C, it has velocity 10 meter per second. Clear?
Okay, sir.
Then if you join, I want the angular velocity at C. Then from A to C, if you join A to C, this will be R. That I have solved, that is 5 meter. Clear?
Okay, sir.
I need a velocity component. This velocity, one component that is perpendicular to this R. This R. Then I have drawn a vector. So drawn a one component that is perpendicular to R. That is this V. It should be perpendicular to R. Clear?
Okay, sir.
Then I need
Yes,
this. Simply then I find this angle, how much it is making with the our original velocity, that is 10. Then it will be 10 cos 37. Here. It's 10 now. 10 is 37. It will be 10 cos 37. That is perpendicular to the R. Clear?
okay, sir.
That is why then omega CA will be how much? Omega CA will be velocity that is perpendicular to the R, that is 10 cos 37. I have written there V, but actually it is 10 cos 37. Just for your understanding. That's why. So answer is cos 37 how much? Tell me. Cos
Sir, cos
37
37.
4 by 5.
1 minute, sir.
5 2s are 10. And there is one more 5. How much?
8
By
by
5. 8 by 5 how much?
so minutes, sir.
1.6 radian per
Yes,
second.
1 point.
So if you look at carefully, the angular velocity at point P with respect to A is 2.5. Angular velocity of C with respect to A is how much? 1.6. So here, in case
Sir,
of
but the
circular,
object is going in straight line only, no, sir.
yeah, it is going in a straight line. It is going in a straight
Then
line.
how
Hmm.
then how it can have angular velocity, sir?
See, actually, how it is, how it is.
How it have angular velocity, sir?
See, it does not means like a object is always in a circular motion. It does not means object. It may be in this path, na curved path. This is also curved. This formula V is equal to R omega is especially valid for circular motion. This formula which I have written, omega is V perpendicular by omega. Clear?
Okay,
This is valid for any curved path. In this formula, that is R. From the center, if this is R, here velocity is perpendicular. Clear? Like this.
okay,
This
sir.
is A, point B is here. Clear? If the angle between the velocity and R is perpendicular here, it will move in it try to move in a circular path. Clear? Move.
Okay, sir.
Clear? I am
Yes,
asking
sir.
at this position, its velocity almost like this, now. Like this. It's one component that is perpendicular now to R. It is responsible for the circular motion now. Particle is moving like this.
Okay, sir.
It is moving in a circular path only, curved. You can say curved path. One component of this perpendicular. So if you find the velocity, if this is R, clear, then always take a component of this V perpendicular to the R. That is V cos theta. It should be perpendicular to R. This is responsible. V cos theta is responsible for this particle to move in a circular path, because in this formula, what we have learned now, V is equal to R omega. This center, this is R. Particle is moving like this. V here, here V, here V. So if you look at carefully, always angle will be 90 degree. So V is equal to R omega. This velocity is perpendicular to the R,
Okay, sir.
small r. That is why I have written omega will be perpendicular by r. Clear? Okay.
Okay, okay, sir.
Can I ask one more question to you?
Ah, yes, sir.
Okay, right on. For example, this particle, let us suppose center is B. With respect to B, what is the omega means angular velocity of A? I'm asking omega AB. Let us suppose velocity is given like this. Clear?
Okay,
20.
sir.
Clear?
Okay, sir.
What is answer? Have you
Sir,
seen
1 minute,
like
1 minute.
this motion, like it is moving like circular and like this? Circular and translation motion. Have you seen this? So we have discussed this. Omega will be 4. Clear? Now write one more question. It's a helical motion. You can write it's a helical. Okay.
Okay.
I have written also. This is a helical. If I ask one more question, write down. Same question I am asking. This is A, B. Clear? And this A is, let
Okay.
us suppose, is 4 meter. This is again 20. And this angle is 37. In this condition, this B is also moving. Let us suppose velocity of B is, angular velocity of B is given. Let us suppose how much I should take. Just a minute.
Okay.
Should I give 1 minute? Let me think.
Sir, you said helicopter.
You can take this 20 cos 37, 23 by 5. Okay. This is 10 meter per second. Clear? So if
Okay.
you, my question is, listen, observer is here only. Omega will be perpendicular component. Okay. With respect to whom? With respect to B. Clear? Divide by R. This is omega AB. Clear?
Okay, sir.
So with respect to V will be VA minus VB. So VA means perpendicular component. How much? 20 sine 37. Up positive minus. This time this is also having velocity 10. Clear?
Okay, sir.
R is 4. Previous case B is at rest. Okay. So there is no velocity. So answer will be omega AB. How much? 20 sine 37. 3 by 5. 5 fours are how much?
Sir. What is that? 12, 2 by 4, 1 by 2, sir.
1 by 2. This is 5 fours are
Radian per second.
20. 1 by 2. How much? Yeah, 1 by 2. That is 0.5. Clear?
Yes, sir.
So omega. This formula is clear to you. In case of
Yes,
circular
sir.
motion, V should be perpendicular to the R. That is why we are taking perpendicular component of velocity. Okay. It is
Okay,
in
sir.
helical motion. It is 100% sure it is helical motion because one component 20 cos 37 will provide the uh, velocity in this direction. Here, confirm it is helical. But our interest
Okay.
is to find this omega, circular motion. In circular motion also there, na? It is moving
Yes,
in a
sir.
circular path, but suddenly it is also accelerating in the rightward direction.
Linear. Okay,
Clear?
sir.
Now write
Yes,
one more question. If I ask you, yeah, question is, okay, next question. Find the Wait, wait on the question. This is XY horizon. This is point P. Clear? Let us suppose this
Okay.
point P has velocity 5 meter per second. Clear?
Okay, sir.
And it is making an angle 37. What is the angular velocity of P with respect to O? If R is 4 meter, tell me.
Sir, 1 minute. Sir, what will be the V perpendicular, sir?
Very easy. Component, take component. 1 minute, okay. Answer.
Okay.
Yes, yes. Okay. One component of this will be 5 cos 37. Then one component will be 5 sin, like this now.
Yes, sir.
Both should be perpendicular. Both the components must be perpendicular. So this is the only component of velocity that is perpendicular to R. Okay, so omega will be this.
Sir,
Okay,
3 by 4, 0.75.
3 by 4.
4.
Very good. That is radian. Clear?
Okay, sir.
If I
I
ask
got it, sir.
one more question, if I ask, see, particle is doing a projectile motion. Okay,
Okay.
my question is, you have started from here. Okay, it is under free fall like this. It is going like this. If you are throwing a projectile with 10 meter per second, clear,
Okay, sir.
and this angle is 30-degree angle of projection, 10, then it is also 10. At same position, velocity remains same. That is what we have learned in projectile. Free fall. This is also same label. Clear? Ground.
Okay,
It
sir.
is also ground. So at same position, velocity is different. Sorry, speed is speed is same. Its magnitude is same, but velocity is different direction. Clear?
Okay.
Clear? If it is making 30-degree from here, then it is also 30-degree. Clear? My question is,
Okay.
what, find the omega with respect to A. Clear? Just before hitting the ground. Just before omega of B with respect to A, just before hitting the ground. Just
Okay,
the
sir.
projectile hitting the ground. Before that, what is omega? This is your homework. Clear? Please solve it here.
Okay.
Very easy. Clear? Okay.
Okay, sir.
Now this is your homework. Now write down what is the meaning of frequency. Frequency in circular motion. Frequency. Write down the topic. Frequency. Frequency means number of revolution per second in 1 second. Clear? That is known as
Okay.
frequency. Let us suppose in 2 pi in one rotation means 2 pi in 2 pi radian particle travel how many revolution? 1. Clear?
Okay.
Then my question is how much frequency? That is 1. How many revolution in 2 pi second? 1. If I ask like this particle rotate, let us suppose this many rounds. 1, 2 round, clear? 3 means
Okay.
like that. 1 round with 2, 3, 4, 5, 6, 7, 8, 9, 10. Clear? 10 revolution. Let us suppose it travel 10 revolution 1 second. How many revolution? 10 revolution. In one revolution, it travel how much? 2 pi. Clear?
Yes, sir.
Then in 10 revolution, how much it will travel? 10 into 2 pi. Clear? This is clear.
Okay, sir. Yes, sir.
So what is this frequency? Frequency means number of revolution in 1 second. Let us suppose in 1 second it travel 720 degree. Means how many revolution? 2. That is frequency. Clear? Frequency
Okay,
means
sir.
number of revolution in 1 second. So for frequency means number of revolution in 1 second. So if you want to write, you can write the formula of angular frequency. Omega is, this is what you have learned, theta by t. Let us suppose in time t, this particle is traveling theta. How much? Theta. In time t, this particle is traveling theta. Clear?
Okay, sir.
This 1 upon t, this 1 upon t is frequency. 1 upon t is frequency. F into theta. F into theta. If you look at carefully, this theta will be 2 pi. This is the formula. Pi. In 1 second, how much theta is? 2 pi. In 1 round, how much theta? 2 pi. Clear? In
Yes,
f
yes.
rounds,
Yes, sir.
2 pi f. This is known as angular frequency. Clear? Omega. Omega means rate of change of angular displacement. So my question is, in 1 second, how much theta? That is 2 pi f. F frequency means if the frequency is f, it means
Sir,
f
please show the
revolution.
previous date, sir. I'm writing.
Yeah,
One
right.
minute, sir. Ah, yes, sir.
F frequency means f revolution in 1 second. Clear? Then in one revolution,
Okay.
How much angle it travel? 2 pi. In f revolution, 2 pi f. This much it travel. This is known as angular frequency. Why it is angular? Because this 2 pi is coming. How much angle it travel in 1 second? Clear?
Okay,
In
sir.
1 second, let us suppose travel this much angle. It started from here, travel this much. How much? This is 2 pi, 4 pi, then 6 pi. Then 6 pi is omega. Or you can say 2 pi. How many revolution travel? 1, 2, 3.
3, sir.
Frequency is 3. Omega will be 6 pi, like this also. Clear?
Yes, sir.
If I have one formula is like, if I ask you, one slide to finish.
Yes, sir.
Okay. If I ask you like this formula, we have written V is equal to R omega. Is this correct? If I ask you velocity is equal to R omega, is this correct? No. Omega is axial vector. Its direction, the direction of omega is same as the direction of V? No, never. Its direction is
Oh,
along x-axis. Along axis. Its direction is like this. See the direction of V? Clear?
yes,
So
sir.
vectorly it is not correct. Direction of omega is, if this is R, omega is, if motion is like this. Omega is out of the plane. Out of the plane means like this. This is the direction of omega. Axis, along axis. I told na axial vector. Because omega what?
Yes, sir.
Theta by d theta by d. Since theta is axial, direction is axial, angular displacement. So omega direction is also axial. Clear? Then
Okay, sir.
what is the right formula? If I ask you this formula, you should remember this. V is V vector equal in vector form. Omega cross R. What? Omega cross R. You should remember this. This is vector form of velocity in circular path. If you take omega cross R, you will get the velocity direction. You know omega cross R, A cross B, how to find from the right hand thumb rule?
Yes, sir.
Yeah, if it is okay, then no problem. After this, write down types of acceleration. Wait, one minute. Write down types of acceleration. Types of acceleration. First is centripetal acceleration. Centripetal acceleration. Next is tangential acceleration. Third is alpha, angular acceleration. Clear?
Okay, sir.
You can write angular acceleration, alpha, angular acceleration. Clear? Now, what is if you look at carefully, I think it's clear to you. I think if you look at carefully, when this particle is moving in a circular path, clear? This is center, clear?
Yes,
From the center, this is R.
yes, sir.
Here, velocity is 2 meter per second. Here, different velocity. Here 2 meter per second. Here also 2 meter per second. Here, this is
Yes,
R.
sir.
And if I ask like how you solve this, let us suppose R is 1 meter, omega is 2 radian per second. Then V will be R omega. It is what?
2 meter per
R is
second.
1, omega 2. So what is this? It is the magnitude of velocity. That is 2 meter per second. So if you check carefully, this is what? This is what? From the center, this is R.
Sir,
This is magnitude. What? This is
magnitude of.
velocity. That
Okay.
is speed. What is this?
Speed.
Speed. Speed is constant, but the direction is changing. Clear? Then it is accelerated. What is? It is accelerated motion. Clear? Now, who is
Okay, sir.
responsible? Who is responsible for the change in the direction? Who is
Sir,
responsible for the change in direction? There
V
should
sin
be,
theta.
let us suppose, no, no, no. If you are taking a rope and you just take one stone, clear? This is your hand, clear? This is your hand,
Okay, sir.
this is rope and this stone. If you give a angular velocity omega like this, you are rotating like this, clear? If you rotate like
Okay, sir.
this, my question is, what is the reason like this particle is moving in a circular path? This is moving like this now. It will move like this, circular path, clear? So who
Sir,
is
the
changing the
stone will be.
direction? Who is
Sir,
changing
we
the
the.
direction? Who is
Sir, we
changing
are
the
changing the
direction?
direction. Like.
Who is changing? Tell me
So the
again.
center, we are changing the
Yeah, very
direction.
good,
So.
very good. There is one force, that is acting towards the center. This is responsible. This is the net force. This particle is having the mass m. Net force towards center. This T is what? Net force towards center. Net tension force. Here force is tension. Clear? Net
Okay,
force
sir.
acting, because acceleration is not coming from anywhere. It is coming due to some force. That force is known as centripetal force. What is centripetal force? It is the net force acting towards the center. So tension, centripetal force, nothing. Okay. It is any force, any type of force that is acting towards the center. So here net force tension is acting towards the center. And this force is responsible for centripetal acceleration. Clear? Because of this centripetal acceleration, this particle is changing its direction. This particle is going like this, left, down, right, up, like this. So the direction of this
Okay.
going to change because of this centripetal force. So centripetal force is nothing. If you want to write, it is, what is centripetal force? Centripetal force. You can write it is the net force. It is the net force acting, what net force acting towards the center. Okay,
Okay, sir.
what's the center? And because of this force, when acceleration is coming, that is centripetal acceleration. And the centripetal is responsible for change in the direction.
Direction.
Change in the direction of change in the direction. Clear?
Okay, sir.
Understood? So why particle is
Yes, sir.
changing its direction? If direction change means velocity change. Direction change means velocity change. Velocity change. The velocity change it is in accelerated motion. What? Accelerated. So circular path or circular motion is always accelerated. Accelerated motion. Clear?
Okay, sir.
Is it? If it is clear, then I think you have no problem. My question is, it is okay. That is like there is net force that is acting towards the center, and this force, this change responsible for the change in direction. It is also responsible for circular path. For circular path. Clear? This circular path is only because of this. Otherwise, it is moving a straight path. You please tell me, this particle is moving in a straight path like this. Who is taking it in a circular path? Who is moving this in a circular path? There must be some force that is towards the center like this. There must be some net force that is towards the center. This force is acting on this particle. Because of this, it is going to change its direction. Okay, like this. This force is known as centripetal force. That is net force. It can be tension. It can be gravitational force. Any force that is any net force that is acting towards the center is responsible for the circular path or for the change in the direction. You know, in our universe, all the planets are moving because of this in a circular path, in a revolution they are doing, rotation they are doing because of this centripetal force. This centripetal force is their gravitational force. Clear?
Okay.
That is
Yes. Okay,
responsible for the change in the direction of object. And what is the direction? Direction, you can see direction is towards center, like this. This is the center. This should be clear. If you solve this centripetal, because of this force, that is centripetal force, there is some centripetal acceleration AC. Clear? It is V square by R. This you should learn this. I will explain in the next class. Clear this. How it is V square by R. But you should learn this centripetal force. Centripetal force will be
okay.
what? M into AC. How much? mv square by r. Clear? This is the centripetal force. Now my question is, now you understand, I think for like if you want to write, you can write. You can, I think you have already written. Now next question is, my question is, if I ask you, particle is moving in a circular path. Clear?
Okay, sir. Yes, sir.
Particle is moving in a circular path only. And here if you look at this carefully, centripetal force is responsible for the change in the direction. Let us suppose it is moving 2 meter per second here. Here it is moving with 3 meter per second. Here 5 meter per second. Clear? Here 7 meter per second. Okay. Then my question is, let us suppose it's R. Okay. My question
Okay.
is like the velocity, the magnitude of the velocity. It is not direction. Okay. 2 meter per second is not direction. It is what? It is the
Magnitude.
magnitude. Now magnitude, who is responsible for the change in the magnitude? This is the magnitude now. Here 2, 3,
Yes,
5,
sir.
7. Who is responsible? There is one acceleration, that is tangential acceleration. If the velocity is increasing 2, 3, 5, 7, then tangential acceleration will be in the same direction as this velocity. It should be in the same direction.
Okay, sir.
Here, if it is decreasing, it will be 180 degree opposite. So this tangential acceleration, this 80 na, tangential acceleration. That acceleration has two components. One component is responsible for direction. One is responsible for change in the magnitude of the velocity. This is known as tangential acceleration. It is responsible for what? 80 will be
Change in.
dv. Its magnitude part. That's why I'm writing in mod. Okay.
Okay,
Here,
sir.
dv by dt. Here.
Yes, sir.
So this is responsible for the change in the magnitude. If magnitude is changing, it means there is a tangential acceleration. Okay, Dinesh?
Yes, sir.
So I think it is clear to you. Let us suppose if the velocity is decreasing like this. Here, let us suppose velocity is here velocity is 7 meter per second. Let us suppose here 5, then 3, like this. Here 2. Let us suppose. So velocity is decreasing because of this acceleration only, change in the magnitude. Here acceleration will be like this. It retardation like we have learned. Clear? It always
Sir, I
occurs.
have a doubt, sir.
Huh.
Sir, in the first diagram, the object starts from here, sir.
Hmm.
The object starts from here and it moves first round. Then the second round will accelerate again like 7 to 9 meter per second, 9 to 11
No,
meter per
I
second.
just
Just
give some
accelerate like
example.
that.
Hey, I have given only example. First case 2, then 3, then 5, 7, like this.
Okay,
Clear?
sir.
It is not like
Yes.
any question. Just for your understanding, I'm telling velocity is increasing. First, it is moving with 2, then it is accelerating like this. Like this. Clear? Like this. Here 2 velocity, then 3, then 5, then 7. So
Okay, sir.
here 2 means it is 1 second, it will travel 2 meter linear displacement. 3 meter means in 1 second 3 meter, 5 meter per second, 1 second, how much linear displacement? 5. Then in 1 second 7 meter. Meaning is that clear?
Okay, sir.
So
Yes,
I'm
sir.
not giving any question, just for your reference. I'm telling if the velocity is increasing, the change in the magnitude of the velocity is increasing with time. It means acceleration will be in the same direction of velocity. If the velocity is decreasing with time, it means acceleration opposes. Here it is retardation. So AT will be opposite to the direction of velocity. Clear?
Okay, sir.
Like in linear translation motion, when you are moving in a straight line, if wind is coming up from the opposite side, then your velocity decreasing because of retardation. Clear?
Okay, sir.
So I think next after this, one thing I want to explain. Clear? Angular acceleration. Now you just tell me if this AT explain what is angular acceleration. Okay. AT is what? dv d like this. Clear?
Okay.
So AT will be what? D by dt. It will be what? R omega. Clear? R is constant because in a circular path, R is constant. D omega by dt is angular acceleration. So AT will be R alpha. This alpha is, or alpha will be AT by R. Okay.
Okay, sir.
This is angular acceleration. All these things I will use in a rotation chapter. Rotation chapter will be very easy for you if you understand this.
Okay.
Okay. Dinesh, one thing like I want to explain. If you have seen like in atom, there is a nucleus. This nucleus, this nucleus and this electron. It is applying electrostatic force. Clear? Because of this
Okay.
force, this electron is moving with v velocity. Clear? It is moving in a
Okay.
orbit, in a circular path because of this electrostatic force. This electrostatic force direction is towards the center. So it will provide the centripetal force. Because of the centripetal force, there is angle between the velocity and r is 90 degree. That is why it is moving in a circular path. Clear? And
Okay.
every orbit you have, I know, I think you are remember or not, every orbit has some orbital velocity. You have learned. That is fixed.
Yes, sir.
Clear? So I think this is clear. Now, one thing like I think I should forget centrifugal force. One topic is last topic when I will wrap up this lecture. Tomorrow we will discuss banking and a little bit concept regarding road. Then this chapter is finished. Then I will explain. Wait 1 minute. 1 minute.
Okay, sir.
So again I will explain. Wait. If you are in a car, clear? Then car is moving. Car is an accelerating frame. Clear? If car is an accelerating frame, then it is a non-inertial frame. In non-inertial frame, we can't apply Newton's law. Then when you are in the car, then you are feeling one force is acting. This is center of the road. Clear? This is a turn, and you are sitting in the car. Then on you, there is one force that is away from the center. That is known as centrifugal force. Clear? That is nothing, just pseudo force. It is imaginary false force. Clear? Which we are feeling
Okay.
while we are in the moving car on a circular track. Clear? When a car is taking a curved path, okay? Then who is stopping
Okay.
you to go away from the center? Friction. The friction between the wheel. This friction will help us to balance this centrifugal force. Who is balancing this centrifugal force? Centrifugal force, friction. Clear? There is one force that is balancing us, that is friction. Have you seen like when you are moving in a rainy day, clear rainy day, then your car slip because of this centrifugal force. Because
Okay.
during the rainy season, the friction reduces the contact. There is not proper contact between the tires and the like road. Proper contact is not there because of raining. So this friction reduces and centrifugal force maximize. It is maximum, okay? Then your car slip. But in ordinary days, this centrifugal force is away from the center on you. That is pseudo force. Then in order to balance, we need a force that is toward the center. Clear? There should be some force
Okay,
that
sir.
is opposite to that, but it should be in equal in magnitude so that your car will not skid. Car will not skid. Car will not skid. This concept you will learn, but my question is when you are moving in a non-inertial frame, in a rotating frame, in a rotating frame like this, circular track, when you are moving in a rotating frame, then non-inertial frame is how much? If you are the observer, this is the car. This is the car, clear? And this is the observer. You are in the car, and this car is moving with certain velocity. Clear? Then, if you are looking from the ground, this this car is a moving frame. This car is moving with some velocity. It has some acceleration. That is why it is non-inertial frame. Then you are the observer in the car. You are the observer in the car. If I ask you apply Newton's law, then what you will do? You need a pseudo force. Then pseudo force is here centrifugal force. That is like this.
Okay, sir.
Here centrifugal force, and its velocity, its value is what? There I think you know mass of the observer. Clear? On which law is going to apply? multiply A is the acceleration of the observer as seen from the ground. Clear? So you please tell me, if a car mass is, for example, uh, you want to apply the law on car. Clear? So mass of the car, clear, you are the observer, into acceleration of car. At what acceleration it is going? Centripetal acceleration. What? Centripetal. It is mr omega square. Uh, that is not centripetal acceleration. V square
Okay,
by r. V is equal to r omega. Clear? So AC will be r omega square. So nothing centrifugal force. This is known as centrifugal force or pseudo force. Pseudo force. And this who will oppose, then pseudo force is going away from the center. Your car will skid. Then who is stopping you? Friction. Clear? Friction will balance this. F will be mr omega square. Clear? Okay.
yes, sir.
So in case of like this non-inertial frame in circular motion, pseudo force is centrifugal force. Its magnitude is what? Mass of the system multiply acceleration. Acceleration of frame. Acceleration of frame as seen from the ground. Direction is away from the center. Away from the center.
Okay, sir.
Clear?
Yes,
Please
sir.
learn about the pseudo force. Clear?
Okay, sir.
Now you please tell me. This is the hinge ring. This is a rope and this is stone. Clear? If I ask
Okay,
you, you are rotating this with some angular velocity omega. Then if you are the observer sitting here, clear? Then on you, you will feel some force. If I ask apply Newton's law, then you will apply one pseudo force like this, one tension force. Clear?
okay, sir.
Then
So
you feel
centripetal
like
force.
on you na. Clear?
Yes, sir.
Then T will be pseudo force. T is equal to pseudo force. T should be equal to pseudo force. Otherwise, the string will break. Clear?
Okay, sir.
Or we can say, in place of this stone, there is a car. Clear? That car should not skid. Then centrifugal force must be equal to the what? Friction. Okay?
Okay, sir.
Is it okay?
Yes, sir.
Or I think you are, if you want to apply, it should be T minus Tf mass of system, that is you, or any like you want on you, like you want your you want to see the effect on you. Then you will feel I'm at rest. Clear? T will be Tf like this also. Okay. This is
Okay,
from
sir.
if you are applying the Newton's law from non-inertial frame. Okay. So I think I will stop
Okay,
this
sir.
lecture here only. But one question also I will ask, like particle is moving in a circular path. Clear? One
Okay, sir.
acceleration is like center, one acceleration is towards tangential. Then net acceleration will be like this. Net of this. Resultant. Clear? What is the angle between AC and AT? 90. Clear?
Okay, sir.
What is the angle of AT with AT? Sorry, 8 net with 80. How much? Theta.
90 minus theta. Okay,
Theta.
sir.
If this theta is like more than 0 and it is less than 90. Clear? Then it will be accelerated motion. Clear?
Okay, sir.
Accelerated. If the AC is like this, clear, and AT is like this, then it will be what? Velocity is this now. From velocity, let us
Yes,
suppose
sir.
it is taking how much? Like this. This is theta. Clear?
Okay, sir.
So here theta is more than 90, less than 180. Here particle is deaccelerated motion, means velocity will decrease. This v will decrease because AT is opposite. Clear? Here v will be like this. Clear?
Okay, sir.
Here particles slow down. Okay.
Okay, sir.
So I will stop here. Thank you so much. Tomorrow I will discuss again centrifugal force, that is pseudo force again. One numerical will solve. Then banking, circular motion is finished. Okay.
Okay, sir.
Okay. Bye bye. Take care. Bye.
Okay, thank you, sir.
Thank you.
Bye.